Hello guys, good afternoon. So you have any doubts from the previous class? What we have covered in the previous class? Overloading and overriding, then abstract and interface, abstract interface, then overloading and overriding. Any doubts in that? No doubts? Next concept is typecasting. 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 What is typecasting? What is typecasting? Converting from one data type to another data type. Typecasting. Converting from one data type to another data type. Converting from one data type to another data type. Now, we have two types of typecasting. One is primitive, another one is reference. One is primitive typecasting, other one is derived typecasting or reference typecasting. Derived typecasting. One is primitive typecasting, another one is derived typecasting. First, we'll see primitive typecasting. Primitive typecasting. In case of primitive typecasting, will be will be making some operations on the primitive data types. Using primitive data types, will be making some operations. Typecasting upon primitive data types. Now, basically, here number type of primitive data types. Number type of primitive data types. We have byte, short, int, long, float, double. Number type of primitive data types. Byte is the shortest range, double is the largest range. Byte is having the shorter range than the short. Short is having the shorter range than the int. Int is having the shorter range than long. Long is having the shorter range than float. Float is having the shorter range than double. Ranges. Okay. Byte is the shortest range. Double is the largest range. Main method, int I is equal to 10. I value I'm trying to supply to the D. I is type of int type, D is type of double type. Trying to supply int value to the double type, auto upcasting will happen. Auto upcasting, that is done by the compiler itself. Auto upcasting from int type to double type. From int type to double type. Auto upcasting. Implicit casting. Implicit auto upcasting. That is done by the compiler itself. Now d value will be double value, that is 10.0. 10.0. I value remains same. I value remains same. But d value will be 10.0. Value of I, I'm trying to supply to the double type D. Now auto upcasting will happen from int type to double type. From int type to double type. Int type means only 10. 10 I'm trying to supply to the double D. Now it is going to convert to the double type, then only it is supplying that value. So D value will be 10.0, I value will be 10. See what is auto upcasting? That means in case of auto upcasting, if you are trying to supply, if you are trying to supply the smaller range to the larger range, you are trying to supply the smaller range to the larger range data type. Possible. Auto upcasting, that is done by the compiler itself. Assume that you have 1 liter of empty can. 1 liter of 1 liter capacity empty can. Then you have half liter of water can. Half liter of water can. That half liter water can, you can consider it as int. 1 liter empty can, you can consider it as double. That half liter can water, can you store inside the 1 liter water can? Empty water can? Possible. There is no chance of wastage. That is why compiler itself will be auto upcasting to the larger type. Possible. Possible. Converting from smaller range to the larger range, that is done implicitly, automatically by the compiler itself. Auto upcasting. Now you can convert from byte to short, byte to int, byte to long, byte to float, byte to double, short to int, short to long, short to float, short to double, into long, into float, into double, long to float, long to double, float to double. Possible. That is done by the compiler automatically. Auto upcasting. You don't have to do anything. compilation success. What is the output? In 10.010 done. I'm trying to convert from byte to int. Possible or byte is having the smaller range, int is having the larger range. Converting from smaller range to the larger range possible. That is taken care by the compiler itself. You don't need to do anything. Then can I convert from short to double? Possible. Short is the smaller one, double is the larger. Can I convert from int to float? Possible. Int is the smaller one compared to float. Float is having the larger range compared to int. From smaller range to larger range. Possible. Now f value you will get 10.0. I value remains same 20 only 10 time. 20.020 done. Here test method I'm calling supplying the I value. I is what type? Int type. Test method argument type is what? Double type. Now while supplying int will be upcasted to double type. Int type will be upcasted to double type. That means 100 will be upcasted to 100.0. Then only it is sent to double type. Auto upcasting.
Casting and typecasting are the same.
What?
Casting and typecasting means the same thing.
In typecasting, we have two types. Is that primitive casting, derivative casting. Yeah. And we have in both we have two types. In primitive also, in derivative also, we have two types. What is that? Upcasting and downcasting. Upcasting will be done by the compiler itself, automatic. We don't have to do anything. That is automatic. Downcasting we'll see. Now, test method return type is the double type. Test method return type is the double type. But here, int I is there. I'm declaring int I variable, assigning 10. While returning, I'm returning int type, but accepting is what? Double type. returning into type, but accepting is what? Double type. Now it is automatically upcasted to double type, that is 10.0. Now this test will be having 10.0, that is only we are printing 10.0. Test method return type is the double type. While returning, I'm returning the int type. While returning, I'm returning the int type. Now int type is automatically upcasted to double type. Then here test method return value I'm trying to print. Test method is executing. Test method is executing. Then also return value printing. Return value also printing. 10.0. 10.0. Test method return type is the int. Test method argument type is the byte. Inside the SOP, in the main method, I'm calling the test method by supplying the byte type of value, byte type of variable I'm sending. Byte B, both are compatible. But while returning, sending the byte type, but accepting is what? Int type. Return type is int type. But returning what? Byte type automatically upcasted to the int type. That is done by the compiler itself. Automatically byte is upcasted to int type. You try to print the value of automatically when you are calling the test method inside the SOP, the return value is going to print. Now the return value will be what? Int type. That is 10. 10.
So can you repeat it again, sir?
Yeah. Here, test method is there. Test method is taking one argument of byte type. One argument it is taking, that is of type byte. Variable name is p. But return type of this test method is the int type. Return type of this test method is the int type. Now in the main method, creating one byte variable b, assigning value 10. Now, while calling the test method inside the SOP, test method I'm calling, supplying the b value, this value. Supplying also byte type, accepting also byte type, supplying also byte type, accepting also byte type, compatible. No issues at all. Compatible. Sending also byte type, receiving also byte type. While returning, this the only I'm returning. This byte value I'm only returning. This byte value I'm only returning. But here, accepting is what? Return. Return type is what? Test method return type is what? Int type, not the byte type. Byte should upcast it to int type. It is done by the compiler itself. Why? Because byte is the shortest range compared to int type. Byte automatically can be upcasted to int type to the larger range. Byte is the smaller range compared to int. Int is the larger range compared to byte. Byte is the smaller range compared to int. Int is the larger range compared to byte. byte will be automatically upcasted to int type, then it is 10. Now, test method return value will be the int type. 10 I'll be getting. In the main method, byte type of variable I'm creating, byte b is equal to 10. Now, double type of variable I'm creating. For this variable, I'm storing the return value of the test method. Now, test method I'm calling by supplying the byte value. In the test method, it is accepting the short value. Now, byte is the shortest range compared to short data type. Byte can be automatically upcasted to short type. Short is having the largest range compared to byte. Byte is automatically upcasted to short. While returning, it is returning the short value. Short can be automatically upcasted to int type. Short can be automatically upcasted to int type. Why? Because short is having the smaller range compared to int range. Int is having the larger range compared to short. Short can be automatically upcasted to int type. Now, test method will be having the int type of value. Now, here int type of value will be there. Int type of value, that is 10. That is 10. That int automatically upcasted to double type. That int automatically upcasted to double type. Then only it is sending to double D. Now, if you try to print the D 10.0, what is the output? Please write down the output. See, simply will get done. There is nothing to write, but what is happening here? What is happening here? Where and all upcasting is happening? Where and all auto upcasting is happening? Where auto upcasting is happening? Here, byte type of variable I'm creating in the main method B, assigning a value 10. Double type of variable I'm creating B. For this, I'm assigning the return value of test1, return value of test1 method. While calling the test1 method, I'm supplying the byte type of value, but the test1 method is accepting the int type of value. Byte is automatically encased to int type. Now, to supply the return value for the test1, I'm calling the test2 method. Test2 method return value I'm supplying as the value for test1 method. I'm calling test2 method by supplying the int value, accepting also int value, test2 method accepting value also int value, compatible. While returning I is the int type, while returning I is the int type, but accepting is what? Return type is what? Longer type. Int is automatically upcasted to longer type. Int is automatically upcasted to long type. Now test2 return value will be longer type. But accepting is what? Test1 method accepting is what? Float type. Long type automatically upcasted to float type. Automatically upcasted to float type. Now test1 is having the float type. Float type value. Now before setting to the double, it is upcasted to double type. From float to double, then only it is sending. If you try to print the D, you will get 10.0. Compilation success, running also success. You can also print the value of D. Ten point zero done. What happens in this case? Error. Where? Where? At line number? At line number 4. 4. 4. Huh? 3. Is it? In the main method, I'm creating the byte type of variable B. Then I'm supplying. Double type of variable, I'm creating the D. D is the double type. For that, return value of test2. Return value of test2 I'm supplying. Return value of test2 method. While calling the test2 method, supplying the byte type of value. Test2 accepting also byte type compatible. To return the value for test2, I'm calling the test1 by supplying the byte type of value. Test1 accepting also byte type of value compatible. Then test1 return type is the short type. But what type of value I'm returning for the test1? Byte type. Byte can be automatically upcasted to short type. Possible. Now test1 is having the short type of value. Now here short type is there. Short can be automatically upcasted to float type. Short can be automatically upcasted to float type. Test2 is having the float type. Float can be automatically upcasted to double type. Possible. Simply done again. Simply done. How to do it explicitly. Explicit upcasting. Explicit upcasting. We don't need to do explicit upcasting. Compiler only taking care of upcasting. Compiler only taking care of upcasting. We don't need to do explicit upcasting. But internally, compiler doing the same. First, int is upcasted to double type, then only it is sending to the double J. Converting I to the double type, I is the int type, int is converted to double type, then only it is sending to J. Double. We don't need to do it explicitly, compiler only is doing internally, implicitly. Still, if you want, you can do it, no issues at all. Simply done.
So what if we remove the double, sir, inside the bracket?
If I remove the double here, what happens? What happens? Huh? Compiler only doing the upcasting. Compiler only doing the upcasting. We are not doing it. Compiler only doing the upcasting. Taken care by the compiler itself in case of upcasting. We don't need to do anything. If you want to do it explicitly, this is the syntax. Same output you'll get. You don't have that output. No issues at all. Compiler only doing the upcasting. Simply done as a message you'll get. Anywhere explicit upcasting is required. Do I need to do explicit upcasting here? Byte type, trying to convert to int type. Int type, trying to convert to double type. This one can be done automatically. This one is can be done automatically. Compiler itself, we don't need to do it explicitly. Still, if you want, you can do it. Still, if you want, you can do it. No issues at all. Byte is converted to int type, then only storing inside chain. Int is converted to double type, then it is storing inside double D2. When I'm calling the test1 method for the first time, straight away I'm trying to supply the int value internally. Compiler will be upcasting this int type to double type, then only it is sending. Why? Because test1 accepting value is what? Double type. Argument is double type. Automatically, compiler only doing the upcasting, then only it is sending. 10 becomes 10.0, it is sending. Separation. Second time I'm calling the test1 method, this time explicitly myself, programmer itself, upcasting from int type to double type. becoming 10.0. That value I'm supplying to the test 1. There is no need of explicit upcasting. Compile only with the upcasting. Still, if you want, this is the syntax. Separation. 2 times from test of double I'll get. Happens here. What happens? In the main method, test1 return value I'm supplying to the D1. First calling the test1 method. Inside the test1 method, byte B is equal to 10. B is the byte type. Now, returning value is the byte type, B type. But here, test1 return type is what? Int type. Byte can be automatically upcasted to int type. Byte can be automatically, internally, it is upcasted to int type. Compiler only doing that. We don't need to do it explicitly. Then test1 is having what? Int type. Int type of return value. That return value int type upcasted to double type. That is upcasted to double type. Then only it is sending to double D1. Int is upcasted to double type. Then only it is sending to D1. Now, double type D2. For this, the return value of test2 I'm supplying. First test2 I'm calling. Byte type of B, supplying value 10. Explicitly I'm upcasting to int type. Explicitly myself I'm upcasting to int type. Then only sending to the test2. Test2 is accepting int type. Here myself only converted to upcasted to int type. Then only I'm sending to the int type. Now test2 is having what? Int type. Myself I'm only upcasting to the double type. Then only I'm sending to the D2. Done again. Is this possible? Trying to convert from the larger range to smaller range. That cannot be done automatically. That cannot be done implicitly. Assume that you have the 1 liter bottle, half-liter bottle. 1 liter bottle is full of water. Half-liter bottle is empty. Can you store the 1 liter bottle capacity water to the half-liter bottle completely? No. Half-liter will be getting wasted. Incompatible, right? That is why compiler won't be taking the risk. In case of downcasting, from larger range to the smaller range, if I want to convert from larger range to the smaller range, that is what we are calling downcasting. In case of downcasting, compiler won't be taking the risk. because of there is a loss of data. There is a loss of data. That is why compiler won't be taking the risk. Here I'll get the compile time error. Double cannot be casted to int. Double cannot be casted to int. Incompatible types. Double cannot be converted to int type. Incompatible types. There is a possibility of loss of data while converting from double to int. Automatic downcasting won't happen. Implicit downcasting won't happen. Compiler won't be taking the risk of downcasting. Why? Because there is a chance of losing data. Still, if you want, still if you want, I don't care about the data, loss of data. Still, if you want, you can do it explicitly. This is how you can do it explicitly. D1 will be downcasted to integer type. D1 is of type what? Double. Double type downcasting to integer type. If I convert from double type to integer type, that is downcasting only. Double is having the larger range. Int is having the smaller range compared to double. So it is the downcasting. Double I'm trying to downcast the integer type. There is a chance of data loss. That is why compiler won't be doing it automatically. Programmer has to do it explicitly. While converting from double to into type, whatever the decimal point we have, 0.9, this 9 will be gone. The whole number 12 will be stored inside the entire. 0.9 value will be losing. That data will be gone. D1 remains same, 12.9. If you try to bring the I, only 12, not that 12.9. Twelve point nine, well, in the main method, byte type of B, value 10. Double type of D1, value is 10.8. Calling the test method by supplying the byte type. Byte can be automatically upcasted to int type or not. Possible auto upcasting taken care by the compiler itself. Test colon, I value 10 I'll get. Now here D1 you are supplying, the D1 is the type of double, but accepting is what? Int type. There is a chance of losing data. Compiler won't be doing it. Programmer has to do it explicitly. Myself only I'm downcasting into int type. Then only I'm sending. While converting from double type to int type, that 0.8 value will be gone. Only 10 I'm only sending to the int type. Only 10. Test colon only 10 I'll get, not the 0.8. Then I'm getting In the main method, creating the longer type of LON. Test method I'm calling. Supplying the double type of value 10.9. Double type of value. Accepting is what? Double type of value. Compatible. While returning, T1 is the double type, but accepting is what? Return type, int type. I'm converting 10.9 to the int type. While converting, 0.9 will be gone, only 10. That 10 I'm supplying to test. Now this test will be having 10. That 10 is of type int type. That int type can be automatically upcasted to longer type or not. Possible. Why? Because int is having the shorter range than the long is having the larger range than int. Auto upcasting is happening. That is taken care by the compiler itself automatically, implicitly. We don't need to do anything. Automatically, int type is converted to lambda type, then only it is sent. We try to bring the LON. It is what? 10. Here, what is happening? Double type downcasted to float type. Float type downcasted to int type. Int type downcasted to byte type. 10.9. Here, 10.9 is the double type. If you want to say exactly floating type, what you need to do? What you need to do? We say here F. 10.9 F. This is the perfect floating point value. 10.9. Now, can float casted to double type? Can float upcasting to double type or not? Possible. Auto upcasting. Auto upcasting to the double type. But here, observe, float I'll be having. Float F is equal to 10 point. What I'll get? 10.9 is the double type. F is the float type. Which is larger, which is smaller? Double is larger, float is smaller. From larger range to smaller range, that is downcasting. Larger range to smaller range, downcasting. Not possible. Incompatible types trying to convert from double to float. So that is why smaller case or upper case. This is also floating value. This is also floating. Floating type, floating value. Now here, double type, sorry, double value, double type. Here, double type, here F1 is a floating type, the T is pi. I'm downcasting to the floating type. Float also can hold a number with the decimal points, right or not? That is why I'm getting F1 as 10.9. That is why I'm getting value as 10.9. Float also can hold a number with a decimal point or simple. But compared to double, float is the smaller range. Double can hold so many decimal points, but float cannot hold that many decimal points. But float can hold the decimal point. Okay. Simply done again.
Decimal points can for float hold.
How many?
Decimal points.
Actually, there is a range. Here, we don't want to know we don't want to know about the ranges. Okay, ranges is not important. Data type range in Java. Ranges. So byte range minus 128 to plus 127. Now float range up to 7 decimal digits, double up to 16 decimal digits. Okay. See here, we are not worrying about these numbers. Okay. Why? Because it is taken care by internally. Okay. Memory management taken care internally. We don't have to worry about the memory management in case of Java. That is automatic. Now, trying to convert from int to byte, that is not done by the compiler. We should only do it into 2 byte. Right or right or wrong? Then byte is can automatically upcast to short or not. Byte can be automatically upcast to short or not. Compiler will be doing like what? Like this. double type of D1 downcasting to int type. That int type can be automatically upcasted to longer type or not. Possible. We have so many conversions. Double D1 10.9090. Now D1 is cast into double type only, compatible or not. D1 also double, converting also double. No chance of losing any data. That a double type, I'm downcasting to float type. Here also, in this range, there is no chance of losing data. Downcasting is happening, but in this range, there won't be any loss of data. In this range, in these decimal points. Then float is downcasting to longer type. Now, loss of data, loss of data. Those decimal points will be removed. Those decimal points will be removed. 10, only 10. Now long is downcasting to int type. 10. Int is downcasting to short. 10. Short is downcasting to byte. Byte is automatically upcasted to double type. 10.0 is not automatic. I'm only doing. Okay. Byte is casting to double type. Byte is casting to double type. I'm only doing it. Byte is casting to double type. 10.0. That double type downcasting to int type. Now that point zero value is gone. Only 10. That a 10 I'm storing inside I. If you try to print the I, that is 10 only. Ten. Okay. Here. Double D1 is equal to 10.90. Inside the SOP, I'm giving a call to the test method. While calling the test method, I'm supplying the D1. While supplying the D1, I'm downcasting to byte type. Now it became only 10. That byte type, I'm upcasting to shorter type. That is 10 itself. Now I'm sending that a 10. Accepting is what int type. Sending is what shorter type. Short can be automatically upcasted to int type. Int type. Now returning int type, but accepting is what double type. That is return type is double. That int type automatically upcasted to double type. Now here you'll be having the double value 10.0 will get 10.0.
So what if we write a byte in place of int, sir?
In case
Test
of what?
of int I.
Uh,
In place of test of int I, if we write test of byte I,
what is the data type?
byte, byt.
Short is downcasting to byte type or not. In this case, directly we cannot send. Short is what? Large array. Byte is what? Small array. Incompatible types. Observe carefully. Loss of conversion from short to byte. So that is why what I'll do, I'll convert it to byte, then I'll send. Now it is fine. If it is short, if it is int here, what happens? Upcasting is happening. Short to int. If it is here byte, if it is here int, upcasting is happening. Upcasting. No, it's not.
Of casting byte there, sir. We can directly explicitly can't we do like we test byte explicit byte can't we do that, sir?
Explicit byte.
If we remove that, sir.
This one.
Yes.
If I remove it, what happens? Here short to type will be there.
No, no, sir. Here in type we like explicit byte type.
Explicit byte, yeah.
Yes.
Like this.
Yes, sir.
Here byte will be there.
No, sir. Here we are making it explicit. And we do it explicit.
Here it remains same. Here this is short. Here byte is there. You're asking here, can I do it as what? Byte.
Byte can make it explicit.
Like this. Whatever you are accepting, that is you are trying to convert to byte. Like this. Like this.
One time byte, so byte byte.
Okay, this.
I'll make it explicit.
Like this.
Yeah, yes, yes.
Correct in fact. Is this the valid syntax? Okay. It is not considering it as a data type. Okay. That means it is not illegal start of expression. Illegal start of expression. If I have created like this, now what happens? It cannot be done like that. If you want the byte type, no, you'll only convert it explicitly, right? So that is why we are calling it as explicit. Compiler won't be doing it. Compiler won't be doing it. If it is what? If it is int type, no. Compiler only doing the upcasting to the int type, then it is doing. If it is downcasting, you only need to do the downcasting, then you should send them. If it is byte is there, you downcast to the byte type, then only you can send them. So this is all about primitive typecasting. Primitive typecasting. Now we'll see derived typecasting. Derived typecasting. Derived typecasting. Class A, nothing is there. Class definition. In the class definition, we don't have anything. Class A. By default, class A is extending what? Object class, whether you give it or not. It is extending object class. Class B extends the A class and also implicitly extending the object class, not explicitly, okay, implicitly. So class B extends A extends object. C extends B extends A extends object. A extends C extends B extends A extends object. Come to the manager one. Manager one. Object type of reference. Object type of object. Object type of reference OBJ. Object type of object. For the OBJ, I'm assigning object type of object. Possible homogeneous assignment. Reference also same. Object also same. A type of reference A1. A type of object. A type of object I'm assigning to A type of A1. Possible homogeneous. B type of reference, B type of object. C type of reference, C type of object. D type of reference, D type of object. All the assignments are homogeneous. That means of the same type. Same type, not the different type. Same type. For the same type of reference, I'm assigning same type of object. Manager 1. Aptech. Simply done you will get. Reference can hold the null value. For the reference, I can supply the null. For the reference, I can supply the null. Reference can hold the null value. Initially, OBJ will be null, A1 will be null, B1 will be null, C1 and D1 also null. That means those references are not pointing to any object. Those references are assigned with a null value. Now, OBJ I'm reassigning. OBJ I'm reassigning. Earlier it was null. Now I'm assigning one object of the object class. One object class object I'm assigning to the OBJ. Earlier it was null. Now it is pointing to one object. OBJ is pointing to one object of object class. A1 earlier it was null. Now I'm reassigning A1 to point to the A class object, A object. Now A1 is pointing to A object. B1 was null. Now I'm assigning one new object to B class. B1 is pointing to B object. C1 was null. Now C1 is pointing to C object. D1 was null. Now D1 is pointing to D object. Null is a literal that can be assigned to any reference variable. Null is a literal that can be assigned to any reference variable. Come to the manager 3. Obj1 null. Obj2 also null. Obj2 value I'm supplying to obj1. Obj2 value is what? Obj2 value I'm supplying to obj1. Now both are null. Earlier it was also null, obj1. Simply I'm reinitializing obj1. A1 and A2 both are null. A2 is null. A2 value I'm supplying to A1. B1, B2 null. B2 value null I'm supplying to B1 value is null I'm supplying to B2. C1 and C2 null. C2 value null I'm supplying to C1. Both are null. D1 and D2 both are null. D1 value null I'm supplying to D2. Now for A2 it was null. Now I'm assigning one object of the A class. A1 remains null only. A1 remains null only. For A2, I'm assigning one object. A2 is pointing to one A object. Now, obj1, it was null. Now it is pointing to a new object of object class. Obj2 remains null only. Obj2 remains null only. C1 was null. Now I'm assigning one C class object. C2 remains null only. Now, wherever here, what is the D value? D1 value is null, D2 value is null. Earlier, D1 value is applied to D1. Now, D2 value is applying to D1. Both are null only. Both are null. Simply supplying the null value. Earlier D1 null supplied to D2 reference. Now D2 null supplied to D1 reference. Simply both are null now. Now D2 was null. For D2 now I'm assigning a D class object. D1 remains null only. But D2 is pointing to one D class object. B1 and B2 was null. Now B1, for the B1, I'm assigning one new object, B class object. B2 remains null only. B2 remains null only. B1, now it is pointing to one B object. Simply done again. Okay? Manager. Here, in the main method, calling the test1 method. Test1 method is the static method. Test1 I'm calling by supplying an object of A class. I'm creating the object new A, then supplying to the test1. Test1 method I'm calling by supplying the A class object, new A class object I'm creating, then I'm sending. Now this test one is having one A class object in the argument. While calling this test one, I'm supplying what? One test class, sorry, one A class object. A class object. In the test one, A type of reference variable is there, A1. Now this object I'm assigning to this A1. This object will be assigned to this A1 of type A. Homogeneous. Sending object is A type. Receiving reference type is A type. This object will be supplied to this A1. Now this A1 will be pointing to this object. Now this A1 will be pointing to this object. Now C type of object creating. C1, new C. C type. While calling test2 is the static method. While calling test2, I'm supplying C1. C1 is the C type. C1 is the C type. Reference I'm sending. Reference. C1 reference. Of type C. Of type C. Test2 accepting C type. Test2 is accepting what? C type. OBJ is the reference. C type reference. Now, for this object, OBJ will be pointing. C1 reference I'm sending. That means what? Wherever C1 is pointing, for the same, OBJ also should point. Wherever C1 is pointing, for the same object, OBJ also should point. Now this C object contains two references, C1 and OBJ. C1 and OBJ. Simply what I'm saying, OBJ is equal to C1. That means what? OBJ is equal to C1. Okay? Wherever C1 is pointing, for the same, OBJ also should point. Now this object having two references, C1 also, OBJ1 also. C1 also, OBJ also. C1 also, OBJ also. Printing C1. Do one thing here. OBJ colon OBJ test3 method I'm calling. Test3 method I'm calling. Inside the test3 method, I'm creating the object to D class. Reference is DOBJ. DOBJ. Creating the new object of D class, assigning to the DOBJ. Now, DOBJ of D type. Test method return type also D type. Return type can be class type. No issues at all. Return type can be class type. Test3 method return type is D type and supplying what type? D type only reference. Reference D type only. Now this test3 will be having the reference DOBJ. Now that reference, observe carefully. That reference I'm supplying to D1. That means what? Wherever this DOBJ is pointing, DOBJ is pointing to an object of D class. For the same object, D1 also should point. D1 also should point. D1 also should point here to one thing. DOBJ. 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 Test 4 method I'm calling. Test 4 method return type is the B type. While returning, I'm creating an object to B, then only sending. Now this test 4 will be having the B class object, B object. That object I'm storing inside B1 reference, compatible. Whatever the object that got created while returning, that object is assigned to B1 then done. Okay, clear, sir. This OBJ and this C1. This OBJ and the C1. We should get the same memory address, and this DOBJ and this D1. We should get the same memory address. Manager. Compilation. Compilation instructions. Fully absurd. OBJ and C1, we are getting the same memory address. DOBJ and D1, we are getting the same memory address. That means OBJ and C1 are pointing to the same object. DOBJ and D1 are pointing to the same object. Understood? Here in the main method, creating the A1 reference, supplying the B object, creating the A1 reference, but supplying what? B object. B is extending A or not? B is extending A. A is a superclass. B is a subclass. A is a superclass. B is a subclass. Subclass type can be automatically upcasted to super type. Subclass type can be automatically upcasted to super type. Auto upcasting. Auto upcasting. B type of object will be upcasted to A type. Then only it is sending. Auto upcasting. B is the subclass, A is the superclass. B is automatically converted or upcasted to A type. Then only it is. Now C is extending B. C is the subclass, B is the superclass. C is automatically upcasted to B type. Now C is the super type, D is the subtype. D is automatically upcasted to C type, then only D is. A is the subtype, object is the super type, object is the super type, A is the subtype. A is automatically upcasted to object type. Auto upcasting, manager file. Manager 6. C can be upcasted to A or not? Possible or not? Possible. C is extending D, B is extending A. New D, object to O. Can I upcast or not? Can I upcast or not? B is extending C, C is extending B, B is extending A. A is extending object, auto upcasting. C is what? C is what type? C is what type? Subtype. Can be automatically upcasted to supertype. D is subtype, automatically upcasted to supertype. D is subtype, can be automatically upcasted to B type. C is subtype, can be automatically upcasted to object type. Compilation success. We get done as now. Initially, A1 is null, B1 is null, C1 is null, D1 is null. Can I send B1 to the A1? B1 is what? Subtype. A1 is what? Supertype. C1 is what? B1 is what? B1 is subtype. C1 is supertype. C1 is subtype. O1 is supertype. Compilation success. Will get done as the output. Now, totally 5 times I'm calling the test method. First I'm calling creating the D object, sending, accepting is what? A type. Can be automatically upcasted or not? C can be automatically upcasted to A type? Yeah. D can be automatically upcasted. Now sending is the B1 type. B1 type can be automatically upcasted to B type or sorry A type or not? Yes. Then creating the D class object, D1 also. D1 can be automatically upcasted to A1 or not? A type or not? Yes. Superclass reference can hold the subclass object. Superclass reference can point to the subclass object. Possible. Main method. Test one I'm calling. Test method return type is the object type. Creating the object to D type. reference variable memory address. While returning D1 of returning, but accepting is what object type. Automatically upcasted to object type. Now here test1 will be having the object type of object that is assigning to obj. Now print obj d1. Both should be pointing to the same object. Both should be pointing to the same object. Obj also pointing to this object. D1 also pointing to this object. Right? Manager. We are getting same reference means it is pointing to the same object D1 and obj. And what happens? Main method calling the test method. Test method return type is C type, creating the object to D. While supplying D1 reference I'm sending D1 D type can be automatically upcasted to C type. C type can be automatically upcasted to A type. Here D class D object calling test1 supplying the D1 reference. D1 can be upcasted to C1 or not? Possible. While returning calling test2 supplying the C1, accepting also C1 C type. While returning C1 I'm returning, but accepting is what B type. C1 can be automatically upcasted to B type. Here B type will be there. B type is automatically upcasted to A type. Here A type will be there. A type can be upcasted to object type O1. Still, if you want, we can do it explicitly. There is no need of casting. D can be automatically upcasted to A type. D can be automatically upcasted to C type. Still, if you want, you can do it explicitly. This is the syntax. Normally, you can do it like this. Compiler only doing the upcasting. Can I supply A1 to the B1? A1 is the super type, B1 is the subtype. Subclass reference. Here, A1 is what? Super type. B1 is what? Subtype. Super type cannot be sent to subtype, but subtype can be sent to supertype. Yeah, supertype cannot be sent to subtype. Subtype cannot hold the supertype. Subtype cannot hold the supertype, but supertype can hold the subtype. Incompatible types. Manager 13. J cannot be converted to B. Error. Still, if you want, you can downcast. You can downcast. This is the syntax. Downcast. A type, I'm downcasting to B type, then only I'm sending. Manager 14. D can be automatically upcasted to B type. Now B1 is the B type. C1 is the C1 is what? Subtype. B1 is what? Super type. Super type cannot be sent to the subtype, cannot hold super type. Incompatible types. E cannot be converted to C. If you want, you can go for explicit downcasting. You'll come to know what is the problem. In case of explicit downcasting of derived data types. D can be automatically upcasted to A type, but A type we are doing the downcasting. B type we are doing the downcasting. A type we are doing the downcasting. Here J1 is the A type. I'm trying to supply A1 to the test one that is accepting B type. What happens? Possible incompatible types. Explicitly downcasting to B type, then only sending. How it is possible? How it is possible? Manager, manager, J1 is a super type. Test method return type is the C type. That is the subtype. A1 is the super type. C is the subtype. Possible or not possible? Explicit. J1 downcasted to C type. Now here C type will be there. I cannot directly send the C type to D1. That is why I'm downcasting here to D type. Then only I'm sending. Fine. Manager 21. Doing explicit downcasting. A1 downcasting to B type separation. Now you will come to know exactly what is the problem if I downcast. In case of derived casting, if I downcast explicitly, what is the problem? A type of reference A2 is equal to A object. A type of reference A2, only A type of object. Creating the A type of object, supplying to A2. Now here, A2 is incompatible with the B2, that is of type B. That is why I'm downcasting to B type, then only I'm sending to B2. Now for A2 is only pointing to the A class object, not to the B class object. A2 is pointing to only A class object at this point of time. A2 is only having the properties of the A class object, not the B class object. Because for A class only I am created the object, not the B class. For A class only I have created the object. Only A class properties will be there. Here I'm downcasting to B type explicitly. Downcasting. Now while downcasting from A type to B type, that B object is not available. That B object is not available. In this case, it is okay. Why? Because I'm creating the object to B. In this case, I'm creating the object to B. B is extending A. Okay, whatever the properties of A, that is inheriting to B class. J1 will be, A1 can be point to those properties. But here, only A object, not the B object. B is not available in the memory. Means B object is not available. A2 of type A. If I downcast to B type, we'll get class cast exception. Class cast exception. J cannot be converted to B. Manager 22. We don't get this second dotted line. Separation you don't get because of the exception. Exception in thread main. You'll come to know what is this thread in the thread class. By default, By default, JVM will be executing the main thread. What is the exception? Class cast exception. Again, we'll come to know what are exception in exception handling class. A cannot be cast to B. Program is abnormally terminating without finishing. Without finishing, program is abnormally terminating. We are not getting second dotted line. Why? Because here I have only created the object for A, not the B. At the compile time, you don't get any compile time error. At the run time, it is going to search for the B. B is not available. A cannot be cast to B. A2 cannot be cast to B. Why? Because A2 is only pointing to A object, not the B object. A2 is pointing to only A object, not the B object. A2 can point to A object. A2 can A2 can be supplied to A type, not the B type, not the B type. Because A2 is only pointing to A type, not the B type. Now A1 reference creating the C class object. A1 reference creating the C class object. J1 can be casted to A1 can be casted to A type, same type. There is no casting at all. No necessity of casting A type. A1 can cast to B type. A1 can cast to C type. Why? Because A1 is pointing to C class object. C is extending B. B is extending A. A is extending object. J1 can be cast to D type, B type, A type, and also object type. But A1 cannot be cast to D type. Now we'll get all these three lines. What is that? 11, 22, 33. We get another 22. 11, 22, 33. Next. J1 can be casted to B type. J1 cannot be casted to C type. J1 cannot be casted to D type. A1 cannot be casted to C type. A1 cannot be casted to D type. A1 it only knows D object. It does not know about the C object or D object. A1 is pointing only for the B. B extending A extending object. J1 can be converted to, can be casted to B type, but A1 cannot be casted to C type or D type. Class cast exception at line number 9. Don't get this 33. Manager 24. Exception at line number 11. 44 we don't get. Understood? Here, auto upcasting is happening. B type is automatically upcasted to A type. Here, A type is downcasting to B type. Here, what happens? There is no casting at all. A type of reference, A type of object. But here, A2 is the A type, B2 is what? B type. Here, if I do it explicitly, what happens? Class cast exception. Because A2 only knows about the A object. It is not knowing about the B object or C object or D object. You don't get this line? Class cast exception. That is why we'll make use of instance operator. Instance of is the operator, and also a keyword instance of. Instance of J1 is pointing to B object. B is extending A. B is extending A. J1 is the instance of A, of course, yes. We get true. Instance of operator will be returning the Boolean value. Now J1 is pointing to the B object. B is extending the A. Now A1 is the instance of A, and also A1 is the instance of B. But A1 is not the instance of C. A1 is not the instance of D. True, true, false, false. And these are 27. J1 is pointing to the D object. D is extending C. C is extending B. B is extending A. A is extending object. J1 instance of object, yes. J1 instance of A, instance of B, C, D. All are done. A1 is the instance of A, A1 is instance of the B, A1 is instance of the C. A1 is not the instance of D. False I'll get. Carefully observe. String can be automatically upcasted to object type. String can be automatically upcasted to object type. Separation. Now don't worry about this. As of now, simply string is also inbuilt class. For the string class, object is the superclass. Subclass can be automatically upcasted to object class or not. Subclass can be automatically upcasted to supertype. Another 29. To avoid the class cast exception, we are taking the suggestion from the instance of operator. To avoid the class cast exception, we are taking the suggestion from the instance of operator. Nested if blocks we have. Basically, initially, creating the A type of A1 reference. For that A type of A1 reference, I'm supplying the C object. C object if block. This is the outer if block. Whether A1 is the instance of A, of course, yes. Going inside to A can be possible. So A1 is casting to A type, finding out whether A1 is the instance of B type. Yes, 2B will be printed. A1 is casting to B. Whether A1 is the instance of C. Of course, 2C is printing. A1 is casted to C type. Now, whether A1 is the instance of E, false I'll get. This statement won't be executed and we don't get the class cast exception. 2A, 2B, 2C. If and only if this statement executes, then only I'll get class cast exception. That is why initially in the if block I'm taking the suggestion of the instance of operator. Then only performing the operation. To avoid the class cast exception, manage the 2A, 2B, 2C. We are not getting the class cast exception. Why? Because I have taken the suggestion from the instance of operator. In the main method, J1, A type. Now, please write the output for this. Everybody has to write the output. Last program, write the output. Note down this. Note down this, all these things. Write the output. Note down. Write the output. Done. This much are you getting? Any doubts?
Sir, explain this program, sir.
Want explanation?
Yes, sir.
Fine. So test method. Test method is the static accepting the object type obj main method creating the a class reference a class object. J1 is pointing to the a object, e class object that is upcasted to a type, c class object that is guys please give me some time, I'll be back. Please observe here C object A3 can be automatically upcasted to A type. D object A4 can be automatically upcasted to A type. Test method I'm calling by supplying A1. A1 now J1 I'm supplying. Receiving is what? Object type. Possible. A is automatically upcasted to object type. Whether OBJ is the instance of A, B can cast to A printed. Then it is downcasting. Downcasting to what? OBJ to A type. OBJ to A type. Now, whether OBJ is what? Instance of B? Yes or, yes or no? A1 is pointing to A. A1 is not pointing to B, is not pointing to C, is not pointing to D. Separation. Test method I'm calling A2. A2 is pointing to B object, right or wrong? Now, A2 can be cast to A or not? Possible. We can cast to A, we can cast to B. A1 is downcasting to A type. A1, A1 is casting to A type. A1 is downcasting to B type. But A1 is not the instance of C. A1 is not the instance of B. We can cast to A, we can cast to B. Separation. A3 I'm supplying. A3 is pointing to C. We can cast to A, we can cast to B, we can cast to C. Separation. A4 I'm sending. A4. A1 is A4 is pointing to D object. We can cast to A, we can cast to B, we can cast to C. Then we can cast to D also. Then separation. Okay.
Yes, sir.
Now I'll take the attendance.